Determine each of the following. And we're asked to find antiderivatives or to integrate exponential functions, and we know that there's a formula that we can use to do that. So we know that the integral of e to the power of ax with respect to x is equal to 1 divided by a, or multiplying by the reciprocal of the coefficient of x is another way that you might put that. So it's going to be 1 divided by a times e to the power of ax, and we get plus c as well as the constant of integration. So for part A, we have the integral of 2e to the power of 4x subtract 7, and we want to integrate that with respect to x. So following our formula, we know that this will be equal to, and we're going to multiply by the reciprocal of the coefficient of x, so we're going to have a quarter multiplied by 2e to the power of 4x subtract 7, and then we also have a plus c for the constant of integration. And then we can clean this up slightly as a quarter times 2 is a half. So we have a half e to the power of 4x subtract 7 plus c. And that will be our answer for part A of this example. So for part B, we have the integral of e to the power of a third x plus 1 with respect to x. So when we divide by the coefficient of the x term, so we divide by a third, that's the same as multiplying by 3, so we'll have 3e to the power of x on 3 plus 1 plus c. So that will be the answer to part B of this example. However, just in case you needed to see this question done again in a slightly different way, we could say that this would be equal to 1 divided by the coefficient of x, which is a third, times e to the power of x on 3 plus 1 plus c. And that would be the same as 1 divided by a third is that 3 that we were talking about back up here. So we have 3e to the power of x on 3 plus 1 plus c. And that is the same answer as what we had in the box. So if you understand that you're just multiplying by the reciprocal, you can go straight to the 3e to the power of x on 3 plus 1. Or if you want to follow the rule a little bit more explicitly, the green working there shows you how to do that. For part C, we're going to have a step in between this expression and actually being able to use our formula. So that is that we're going to have the integral, and we're going to separate out this fraction into e to the power of x divided by e to the power of x's square root. So that's the same as e to the power of x to the power of a half. And then we're going to have plus 1 divided by e to the power of x to the power of a half. So that power of a half being the square root that's appearing in the denominator. And we're going to integrate all of those with respect to x. So that's the same as the integral of e to the power of x divided by e to the power of a half x. So when we do power and power again, we multiply those powers together. Plus, and this could actually be written as e to the power of negative a half x, so that we've got our expression in the numerator rather than the denominator. And that's still with respect to x. And we're still not quite done yet on just cleaning this up. The next thing we need to do is remember that our index laws say if we have the same base and we divide, we can subtract powers. So this will give us the integral. And when we have e to the power of x subtract a half x, that will just leave a half x as our first term. And then our second term remains the same, e to the power of negative a half x. And we're going to anti-differentiate that with respect to x. And now we're finally up to the stage where we can actually perform the integration. So this is going to equal, and when we divide by or multiply by the reciprocal of the coefficient of x, that is a half. So the reciprocal of a half is 2, so we get 2e to the power of a half x. And then here we're going to have minus 2, which is dividing by negative a half, times e to the power of a negative a half x plus c, which is the constant of integration. So that is going to be the answer to part C of this example.